Let's now dive into how to solve inequalities. So solving for x. To solve for a variable x in an inequality, first remove the constant and then remove the coefficient. These are the same steps that we took to solve an equation, as you may have seen in our previous chapter. So let's say we had negative 4x plus 7 is less than 23. We first remove the constant, 7, and then we remove the coefficient of our variable, and then that will leave us with the inequality and just having a variable on one side and a value on the right side. Now, one more thing that you need to keep in mind when you are solving inequalities is the symbol must be reversed whenever you divide by a negative value. So here we have negative 4x is less than 16. So in order to get rid of the coefficient, negative 4, we need to divide both sides by negative 4. That leaves us with x is greater than negative 4 because we have to reverse this from less than to greater than. When you are checking the answer of the inequality, you want to plug in a number from within the inequality and another number from outside the inequality to show that the inequality is correct. Here we have x is greater than negative 4. So you want to try negative 4. That should not work. And then you want to try a value slightly larger than negative 4, and that should work. So negative 3 is larger than negative 4. If we plug that in, negative 3 times negative 4 is positive 12, plus 7 is 19, and we get 19 is less than 23, which is true. But if we plugged in negative 4 instead, negative 4 times negative 4 is 16, plus 7 is 23, and 23 is not less than 23. So you use the inequality that you get as your answer to help you figure out what numbers you should plug in. And it should be the number included in the inequality, and then a number on the other side of the inequality symbol. Let's try a few practice questions. Solve for x and check the answer. Question number 1. 2x plus 5 is greater than or equal to negative 3. Question number 2. Negative 5x minus 1 is less than 9. And question number 3. Negative 4x minus 7 is greater than 13. Pause the video, try these practice questions, and then press play when you are ready. Okay, so question number 1. 2x plus 5 is greater than or equal to negative 3. So step 1, remove the constant by subtracting 5 from both sides. Positive 5 and negative 5 cancel each other out. Since we subtract 5 on the left side, we keep the inequality balanced by subtracting 5 on the right side. That leaves us with 2x on the left side. Negative 3 minus 5 leaves us with negative 8 on the right side. Step 2, remove the coefficient 2 by dividing both sides by 2. When we do that, that leaves us with x on the left side. We're dividing by a positive number, so the symbol stays the same, which is greater than or equal to. Negative 8 divided by positive 2 leaves us with negative 4. So the answer that we get is x is greater than or equal to negative 4. And now step 3, check the answer by plugging two numbers into the original inequality. So when we do that, we have x is greater than or equal to negative 4. So we should try negative 4 to make sure that the statement remains true. And then we should try a value smaller than negative 4, which is negative 5, to show that it would not work. So we'll start with the smaller values and then plug in the larger values. So since negative 5 is smaller, we'll start there. 2 times negative 5 is negative 10. Negative 10 plus 5 is negative 5. And that leaves us with a false statement because negative 5 is not greater than negative 3. So negative 5 does not work. But let's try negative 4. 2 times negative 4 is negative 8. Negative 8 plus 5 is negative 3. So as the value got larger from negative 5 to negative 4, the expression on the left side got larger. And when we get to negative 4, the left side equals the right side, which is true. Negative 3 is greater than or equal to negative 3. So that lets us know as this value gets larger, this side will get larger, which will keep this statement true. So that confirms that this is the correct answer. X is greater than or equal to negative 4. Let's take a look at question number 2. Negative 5x minus 1 is less than 9. Step 1, remove the constant by adding 1 to both sides. That leaves you with negative 5x on the left side. 9 plus 1 leaves you with 10 on the right side. Step 2, remove the coefficient, which is negative 5, by dividing both sides by negative 5. When we do that, that leaves us with x on the left side and 10 divided by negative 5, which is negative 2 on the right side. And since we are dividing by a negative number, we must reverse the sign from less than to greater than. So the correct answer for question number 2 is x is greater than negative 2. And now step 3, we want to check the answer by plugging two numbers into the original inequality. So since we have x is greater than negative 2, we should try negative 2, and it should not work since x cannot equal negative 2. And then we can plug in negative 1, since x should be larger than negative 2, and negative 1 should then work. Negative 5 times negative 2 would give us positive 10. Positive 10 minus 1 gives us 9, and that leaves us with a false statement. 9 is not less than 9. They're equal to each other. So far so good. If x is larger than negative 2, then let's try negative 1. Negative 5 times negative 1 is positive 5. Positive 5 minus 1 is 4. 4 is less than 9. So we wind up with a true statement. So negative 2 does not work, as it should not. We go larger. Negative 1 does work. So this is the correct answer. X is greater than negative 2. Question number 3. Negative 4x minus 7 is greater than 13. Step 1, remove the constant by adding 7 to both sides. The constant negates on the left side, leaving you with negative 4x on the left side. 13 plus 7 leaves you with 20 on the right side. The second step, remove the coefficient by dividing both sides by negative 4. When we do so, that leaves us with x on the left side and 20 divided by negative 4, which is negative 5 on the right side. And since we are dividing by a negative number, we must reverse the sign from greater than to less than. So the answer to question number 3 is x is less than negative 5. We want to check the answer by plugging two numbers into the original inequality. So since x has to be less than negative 5, we'll try out a number less than, which is negative 6. That should work. So negative 4 times x is negative 4 times negative 6, which is 24. 24 minus 7 is 17. And that leaves us with a true statement. 17 is larger than 13. So for a number that is less than negative 5, this did work. Let's try negative 5. Negative 4 times negative 5 is positive 20. 20 minus 7 is 13. And 13 is not greater than 13. They're equal to each other. So this is a false statement. So that confirms that the answer to question number 3 is in fact x is less than negative 5.